Hello YouTube. I thought I'd do a quick video about this transistor tester. It's actually more of a component tester. It does more than just transistors. And I actually found this after watching a video by Julian Ilett, and I hope I'm pronouncing that correctly. I'll link his video down below anyway, so you can check that out. And the version he had was actually without an enclosure, so it was all out in the open, and I was actually looking to buy that one off eBay and found this one instead. And this is a little bit more expensive than that type, but it looks like the functionality, the software and sort of the component testing it does is very similar, if not the same. So we'll take a look at that now. And I've got some parts on the bench downstairs that we can test with this, and some digital multimeters that we can compare with. And I don't have an LCR meter to do comparisons with. This was going to fill that void for me until I needed something a little bit more serious. But we'll have a look at that nonetheless, and we'll tear it down and see what it looks like inside. So we'll run downstairs and I'll show you the eBay page first, and then we'll start doing some testing. And I'm hoping that the rain outside isn't coming through too badly on the mic. Of course it hasn't rained all week, but the moment I try and record a video, it just starts bucketing down. And it's sort of raining and then it will stop for a bit, so I'll try and work in between. I'm hoping you can still hear me. So here's the listing for this transistor tester, as they call it. It actually tests a lot more than just transistors, and we'll get into that a little bit later, but this is from a seller called Tom Top Wholesaler, and it cost me $38.15 Australian with free delivery, and it did take a long time to deliver, so it probably took 2 weeks or so here in Australia, and that was from Shenzhen in China. And so I'll just give you a quick look at some of these pictures here, because this is going to give you a good idea of what it looks like. And mine does look pretty much exactly the same as this, except for mine has the extra Fish 8840 logo here, and I think that might be you know, just the seller, or I don't know, the distributor's little branding that they stick on it. So there it is. You can sort of see that there. It's the same sort of screen. It's backlit with white text or graphics on a black background. And same sort of thing, 9-volt battery compartment, and it did come with this little ZIF socket, which I'll show you in a second as well. So that just plugs in the front. So that's all pretty nifty. So they describe it as an LCD ESR meter, transistor tester, capacitance, inductance, diode, triode, MOS, NPN, PNP. So it does all those sort of things. Okay, so it's a 128 by 64 graphic LCD. It's a 9-volt battery that it takes, and 2-second detection time, and 1 minute for bulk capacitor. So if you've got a really high rated farad capacitor, it'll take longer to sort of, I guess, charge it up and take the readings and do all those sort of things. Note, please make sure capacitors are discharged before testing. So I'll note now that the device came with no manual or documentation at all. So but it is pretty much plug it in and stick your component in and off you go. I guess you've got the specs here on the eBay page. And it does say just to discharge capacitors before you plug them in, so you don't end up blowing up the device. So the capacitance test range is 25 picofarad to 100,000 microfarad, which is actually really large. And that's probably where they're saying it will take a minute. Inductor is from 0.1 millifarad to 20 henries, which is, again, huge. I don't think I have any components like that around, but yeah, we'll see how we go. I've got a small handful of parts here that we can test with. Half an ohm to 50 mega ohms, which again is pretty substantial. Yeah, and that's pretty much it. So the package is E0346, and yeah, I don't know where that number relates to anything on the product, but there you go. It's probably the distributor's part number. So what we'll do now is I'll bring you in closer and we'll have a look at the tester. I've got a ProTech 608 digital multimeter and a Fluke 116, and a handful of parts here. So we'll go through these, we'll test a few different bits and pieces, and we'll just see how accurate it is, how easy it is to use, and how fast it is. So we'll do that now. Okay, so you can see the tester here is in a neat little package, and it's rattling because in the battery compartment it came with that that ZIF socket that we saw on the eBay page. So that's a 14-pin ZIF socket. As you can see, it's just a standard little cheapy ZIF socket, but it's got the arm to open and close the connections. And then on the front side, actually I'll stick a battery in now. So it's just got the leads here. I've just got a standard 9-volt. It just plugs in like that. Okay. And then the ZIF socket just plugs into this little pin array here, which is a little female header. And the idea is that you can just grab your component and just stick it in pretty much anywhere. Each sort of row, sorry, each column is labeled with a number 1, 2, and 3, 3, 1, 2, 3. So as long as you get a different column with your leads, it'll be able to determine what it is and test it and give you some results. So this little ZIF socket just plugs straight into the pin header there, like that. Yep, straight in. And then you can use this to, you know, put your components in and then clamp down. Now it's not the tightest connection, and the other thing is it's a little bit hard to see the numbers down here, but they do have the numbers at the top. So you just still need to make sure that you don't put your components in the single column, otherwise it's just shorting across the one column and doesn't know what's going on. I suppose if you had some really like thick leads, you could use this instead, or you know, some flat leads like an IC sort of type design, or some of those. You're not going to put an IC in there, but sort of like the flat leads, which you have a bit of difficulty fitting in these standard sort of female pin sockets. You can use that. So this is the design. It's pretty nice. The plastics don't feel great. They don't feel bad either. The labeling's a bit, you know, off center, and it's all a bit sort of thrown together, but it was only, what, $40, less than $40. It's a little bit sort of smoky over there, but we'll turn it on. Test, turn on. There's your Transformers logo again. Now it is a little bit dim, and what you see there, I'm just looking on the screen of the camera here, that's pretty accurate to what you're seeing. So it's very glary plastic, so you sort of got to look on it straight on. Looks like they've spelt unknown. Obviously nothing plugged in, so it's just going, whoa, nothing, what's going on? Don't know what it is. So you do want to be looking straight at it. You can see that, you know, there's a glare off the light there, but not great sort of viewing angle or contrast. So yeah, but that's all right. You can deal with that, I suppose. And it's just powered off automatically there to save batteries, which is good. Now, I'll just throw a component in and we'll test it. So you got this little capacitor here. Just plug it straight in, hit the test button. There it goes with its logo, and it's saying tester, thinking about it. Battery is 9.2 volt, and it's testing. And I'll zoom you in here. So it looks like it's come up with a capacitor. V loss is 0.0%. It's a 948.0 nanofarad, and ESR is 0.25 ohm. And you see it's got 2, 3, and it's plugged into 2 and 3. And I don't know if you can see the marking on top of that capacitor. There you go, 105K. So we're a little bit low on the reading there. And you notice that it does actually take, it says 2 seconds test time on eBay, but it takes a little bit longer because it shows a logo first, and you know, which is a little bit annoying, but nevertheless, we'll keep going. So actually, what I might do is bring in the fluke meter. So we got a little device here. Sorry, capacitance. Try and get it right this time. 956. 957. And we'll chuck it back in here and just confirm what we got. You see them, you got to wait for it to boot up, for it to do its thing. Okay, 949. So that's actually pretty decent reading compared to the fluke. Let's just give the ProTech a go. .966. So you can see where, yeah, it's actually doing pretty well compared to these not very expensive but relatively good quality meters. They all tend to be agreeing, so that's pretty good. Now I'll just shuffle these aside and we'll grab another component. Grab another capacitor. So we've got a 400 volt capacitor here. This is your standard sort of filtering cap on like a line level input to a power supply, something or other like that. Anyways, we'll plug this in and give it a go. So we're going from 3 to 1 terminal. I'll zoom you in here as we hit the test button. Testing, and we've got 147.4 nanofarad and 0.1% loss between pin 1 and 3, and as you can see, 1 and 3, and we're saying, was it 147.4, what have we got in the case here? 154. .149, so it's a little bit higher than the eBay tester, but yeah, that's still very close. So no worries there. We'll take the fluke now. Now the fluke is by far the fastest, 149, but it doesn't have the decimal place either. So there you go. But so you can see that using this, you hit the button and you got to wait for the logo, and then it comes up with the name and the version and the battery, and then it starts testing. So when it says 2-second testing, you've actually got an extra couple of seconds at the start. So I have a little Nichicon capacitor here. It's a 470 mic, 63 volt capacitor. So it's a fairly large, I suppose, relatively large capacitance, and we'll see how fast it can measure this. And it apparently does ESR as well, so we'll see what it does there and see what sort of ESR reading we get. And I actually have an ESR meter here that we can compare to. So I'll plug that in. Okay, battery 9.1, testing. So it's taking a little bit longer. And there we go. So we've got 421.8 or 0.3, what's that? Looks like 0.3 microfarad. And an ESR of 0.10 ohms. So I'm going to take this same capacitor, and I've got one of these little EVB ESR testers, and it's one that I bought online. So we'll give this one a crack. It's already turned on, so it's already zeroed out. We'll just make sure that it is zeroed, and then we'll just put the probes here, and it's 0.10. So that's exactly the same. So that's pretty impressive. We'll also take a capacitance reading on the fluke here. Just get you to see that screen, and here we go. 252.431.433. There you go. Microfarad, and that was relatively quickly. That was definitely faster than the little eBay transistor tester. Moving right on. Let's see what else we got now. A little bunch of parts here. So let's try some inductors. Now this is a little 334C is the marking on top. A little through hole inductor. Little wire round, so we'll just stick that straight in. Bending the legs here, but that's all good. Alright, fire that up. Testing. 0.31 millihenries. And we got 334, so I'm assuming that's like, 0.334 millihenries. 0.2 ohm resistance. Now, my other meters here won't do inductance. They're not LCR meters. They're just your standard sort of multimeters. But I do have some other inductors we can try. So this is a 470. It's marking a 470 on the top of that, as you can see. We'll just plug this in. It's a little through hole as well. It's got a very short lead, so I hope that they can. Actually, in this case, it's not quite gonna fit there. So I'll try this little thing out. Is that gonna work? No, that's not gonna work either. Maybe just. You can see it's like particularly short leads on this component. Let's give that a go. 0.05. Okay, we've got a fairly chunky inductor here. It looks like it's like a high current for like a switch mode power supply of some sort. So we'll give this one a shot. Now that is actually too big to fit in these pinheads. I'm not going to force it, but you can see those pins on this through-hole pins are actually quite a thick diameter. So we're going to try out this little ZIF socket. So that's just clicked into there. Let's see what we get. .32 microhenries and a 0.2 ohm resistance. So 0.32, and we've got a 331 marking. So that sounds pretty good. I don't know what the tolerance is on these things. I do have one of these sort of axial inductors here. They look like a sort of like a fat resistor, but we'll give this one a go too. I'll just use a ZIF socket again. It's already in there, and I'll just make sure I've got pin 1 and pin 3, so that should be fine. Unknown or damaged. Doesn't like it. What have I done wrong? Oh, do you think that might be the issue? That sort of rocks there a bit. It's not giving me a great deal of confidence. Go again. I'll hold it in this time. The ZIF socket doesn't really feel great. There we go, worked that time. 0.01 millihenries, 0.6 ohm. There you go. Now what else have we got? Oh, it looks like we've got a little power transistor of some sort. So we give this one a shot. Now I'm going to do it without the ZIF socket. So we're looking to make sure we get separate columns on each one of these. So we go 1, 2, 3. In here we'll do it. Push that in. Let's see what we get. There we go. It's a BJT NPN, and our pin numbers are 1, 2, 3 off of this here, and they are the emitter, collector, and then the base. And our HFE is a 147, and our forward voltage is 636 millivolt. That's excellent. And we've got a nice little graphic diagram here to show us the pin orientation. So there you go. That actually works really well. Now, I wouldn't mind doing an LED. I've got two different types of LEDs. I've got standard sort of, these are the 5, now what do they call them? The T5 or something or other, I believe is the just a standard through-hole LED. This is a green one. So if we go between 1 and 3, I want to see if it flashes when it tests it. There you go. Yeah, you can see that blinking there. And there it is. So we've got a forward voltage of 1.95 volt, capacitance of 11 picofarads. So it actually gives you capacitance as well. That's very cool. And it gives us our anode cathode direction. And what's this? Current, 10 nanoamp. It's cool that it also blinks at LED, so you can immediately see if it's actually going to light up. It's obviously putting enough voltage through the pins here that it can illuminate the LED. Now I've got a clear, I don't know what color this is, but it's one of these clear case ones. So I'm going to stick that one in now, and we'll see if it blinks and what color it is and what results we get. Okay, so it looks like one of those bright blue 2.76 volt, and it's a 19 picofarad and a 6 nanoamp. And again, we have the display. That's handy in itself, just to be able to quickly and easily see what your forward voltage is and what color it is. I suppose in this case, it blinks it for you. What else have we got? I've got like a big power resistor by the looks of it, so we can give that one a shot. And I'll be able to test this one on the multimeter as well. You might be able to read the color bands off there if you know how to read them. 99.64 kilo ohm. 99.2, 99.3. So that's spot on, and we actually get better resolution on the little cheapy eBay tester too. So that's always handy. We'll give it another test of a resistor here. I'm not sure what value this is. 150.1 ohm. 149.4. So we're only like an ohm or 1.1 ohms difference between the two. So next we'll take a screwdriver to this, and looks like we've got a couple of screws up the top there, and something inside here maybe. No, it looks like 2 screws. So we'll undo these, and I'll take you to the other side of the bench there, and we'll have a bit of a closer look at the insides of this thing. And I'll remove those. Now it's quite a small hole there, so I'm not using my best screwdrivers here. It's just one of these little mini sort of precision screwdriver things. It does feel loose, but now it's coming apart, but I'm hoping that this is just a clip. I can't, oh no, hang on. Okay, this is why the stickers are here, because I was going, why would he bother putting stickers inside there? Well, obviously, that's why. So it's a warranty sticker. Okay, there we go. So, the screws drop out there, little self-tappers, and it looks like that's not going to fit back through the hole here, so it's sort of captured that back panel, but that's alright. That's it, that's all she wrote. I'll zoom you in now so you can have a bit of a closer look. So it looks like we've got a number of test points and things around here, or what are they? Actually, no, these are gyny stickers. Oh, it's one of these horrible ones that won't peel. But I'm not sure if this is a test for testing, or it looks like, well, we've got inductor here, capacitor, diode, resistors. So there's a bunch of DC here, so it's like an extra little, LED as well. Oh, that's interesting. I'm just looking at the other side of this. So it looks like here we've got like a power LED, or I originally thought that was like a battery flat LED because nothing lit up, but now I can see why. Flip it over, and there's nothing there. So that's where the LED would have gone, and I believe maybe this circuitry is something to do with, you know, if the battery is going flat, or some sort of indicator LED that goes up there. So that's interesting, they didn't fill that. You can see it's a fairly recent design, and fish840.taobao.com. So he's actually, looks like this is the guy or the manufacturer that's built this thing, and there he is with his transformer symbol again. And you can see the back of this female pin header. You can see you've got your columns, and that lines exactly up with this. So you can see the configuration they've got here. So it's just a row of columns, and you can see, you know, where this and this one here are the same, and you can work that out with the numbers on the front anyways. And it looks like this is the back of 2 through-hole tactile switches, and the overlay here is obviously just embossed, but they're actually pretty nice. It's a very positive actuation, so it's none of this mushy stuff. Yeah, it's got a good tactile feel to it. Looks like an 8 megahertz crystal. I'm going to give you a quick look through the desktop magnifying light here. This will give us a bit of a better view. I do have a USB microscope, but for this I'm just going to give you a quick glimpse through here, and we can see that the microcontroller there, we can get some decent light. There we go. It's an Atmel Mega 328p, which is, I guess that's very common for the Arduino framework. I think they use the same, Arduino hardware use the same MCU on those as well, and it's running at 8 megahertz with the crystal there. We've got like a flat flex ribbon, and it's soldered directly to the board there. So no socket. Obviously this is built to a cost, so there's no sockets or headers or plugs or anything. It's just you know, you got your wires directly on the board here. You know, like this. I just solder them straight in, and your ZIF socket is just soldered directly on there, which is a bit, you know, bit rough and ready, but like I said, bit of solder flux left over, should be right. So it's a bit rough, but again, it's very cheap, so I wouldn't expect anything much better than this, really. So I'm going to undo these screws on this PCB, and we'll flip it over and see the front side and the LCD, and see how that looks. So I got these horrible little self-tappers out. There's 4 of those, and I'm going to carefully, because I don't know, oh no, it seems loose, is it? Yes? No? Okay, so yeah, I do need to be a little bit careful here. You can see in there though, there's our LCD, and it's literally just glued straight in with a hot glue gun. I'll bring the magnifying lamp in here again. You can see it's just hot glued straight in there. The flex ribbon cable is soldered onto this board, so it's not built for service, of course, but there you go, and you got your little tactile switches and your little test points there, and there's your in-circuit serial programming port, which is your SPI bus with 5 volt by the look of it. Yeah, so that'll be to program the microcontroller or the Atmel AVR. Now I'm going to carefully try and, oh, this just feels horrible. So there's our programming port there to program this. And I'm just seeing where the regulator is, and it's obviously this one down here. You can read the silk screen there, it's a 7805, and the filtering capacitors on each side of it. Okay, so there it was. A very quick run through and look at the eBay transistor tester. I'll leave links below for Julian Ilett's review of his configuration of what looks to be a very similar design. And I'll leave a link to the eBay item, and if you like this video, please subscribe and give it a thumbs up, and I'll see you soon for the next one.